Okay, so this is going to be the first of a few series of videos that I'm making about how to use my program NetTracer3D. So what this program is it's a program for analyzing three-dimensional images, mainly the kinds that you would get from microscopy or from doing medical imaging, mainly for scientific analysis. So if you were trying to establish some kind of quantitative analysis for a paper or create cool looking 3D overlays and figures. That's some things that this is good for. And the way it kind of works is it is designed to take 3D images and convert them into networks mainly, and it also has a variety of other morphological and spatial analysis options. So I'm not going to go over everything it can do in these videos, but I will do some demonstrations of different analysis as sort of a quick start to help people get started. So first of all, let's just talk about installation. You can find a lot of instructions about how to use and install NetTracer3D from its Python package page. So if you just Google it, you'll usually just come up with something like that. As you can see, it's going to be one of the first results, this pi thing. So that's going to be this page right here, and it has some instructions. It will point you to the documentation too. So what this is a very detailed description of the program, including installation instructions, written out tutorials, and it also describes every single function available in the program. So if you have any highly specific questions ever about the program, that's where you're going to want to go to address that stuff. So installation, there's a few different ways to do it. To get the complete program, which I recommend doing, you'd want to do it as a Python package. So you would just go to the Python website here, download one of the more recent releases. I would recommend one of the more recent version 3 releases. It's built for the version 3. I would probably do like 3.11 up, just because you want it to be compatible with all of the various packages within NetTracer3D. So you're going to want to download the Python install manager. And so like looking at these Windows releases, you can download the Windows installer. I don't really use Mac, so I can't really talk about that. But let's say we're going to run this. You're going to want to make sure that you choose a few options. So one that you want to select is add Python to path. Basically all this does is it lets Windows see the Python executable program from any folder, and then you can hit install now, and it will go ahead and do that for you. And then something that you would also want to make sure is that it's installing this program called pip. Pip is the program that Python uses to install Python packages from the internet, which is what you want to make sure you have set up, because it makes the program very easy to install. So once you have both Python and pip installed and on your path, you can go here, or you can search up, press Windows key R, and then here you type CMD just to open your command prompt. And you can interact with Python through the command prompt. So just as an example, to verify that your Python and your pip were installed correctly and are on your path, you can type something like this, where Python. So you can see it's finding it on my path. I have previously had version 3.13, and I just installed 3.14, so it sees both of them. I don't know which one it's going to use. It's probably just going to pick one. But you can also ask where pip. So there you go. There's also the pip program there. So once you have Python and pip set up, and you can do that, just to install it on your machine itself, you just use the command pip install NetTracer3D. You'd hit enter and run that. It will probably take several minutes if you've never installed any of the Python packages on your computer before, because some of them can be bigger. So just hit that and then wait for it to finish running. And alternatively, if you want to also have the 3D image visualization features, you actually want to run this command instead of just the standard pip install NetTracer3D. So you would add this viz thing at the end, and all this pretty much does is it also installs something called Napari along with it, and that's what you need to run the 3D visualization tools. You can manually install Napari in the base package afterwards if you didn't install it this way, so that's just something that I'd recommend doing. Like if you were going to install it in the Python package, I would just use this one for the most part as the default install command. And if you're having some trouble with this, perhaps you didn't put it on your path, maybe just try reinstalling it and make sure that you check that option. You can edit your Windows path directly through the control panel if you just look up edit the system environment variables, but I'm not going to go over exactly how to do that. It's easier just to have it automatically go ahead and set that up for you. Now, once you have NetTracer3D installed, you should be able to run it from the terminal here. If you just type NetTracer3D, Python has this like package directory set up that you can call certain commands from directly if the packages are organized to let you do that. So if you just type this command, it will open the window for you, and you'll get it here. If you don't want to go ahead, if you don't want to bother with doing all of that for the installation, you can also download a compiled version here. Currently, it's living in this Zenodo directory, and you can find that on this link also. This is version 1.24, and so this version, you would just download this entire folder called dist here, and then you would unzip it. It's kind of large, it's 7 gigabytes, mostly just all of the other packages that come with it. But once you have that set up, if you were to go to your, where is it? Yeah, wherever you put it, you would just click on this and you'd be able to run it. This one has a few less features, so I would recommend trying to do the Python package first, but it might be easier to install overall. Most notably, it doesn't have the 3D display features, so if that's something you're into, you would want to try to do the Python package. And it also won't get updated as often because I have to sort of manually compile the program into that executable there. So let's just go over the window for the program here. So you see a few menus at the top. There's this control panel at the bottom, and there's these things on the side. So let me just bring you through doing some of this. So here's an example data set. And so this is your main image window. So when you load images, they'll render here. You can do image, adjust brightness, contrast to make the display more or less visible, depending on what you're doing. This gives you 4 channels to work with. So you've got these and these overlays. The first 2 channels, these are the ones that are actually going to be mainly used for making networks. And then these ones are just for additional visualization purposes. And then interacting with the window, some of the options you have here, this is the zoom. So click to zoom in, right click to zoom back out. You can click and drag to zoom into a specific target, or you can press this home button and this will always bring you to the max zoom out again, which can be useful if you kind of get lost in your image somewhere. We have this pan option. So, you click on the hand, you get to pan around. You can also interact with these objects too. So, in this specific window, these are my nodes, so I can click on them. I get information about them up here. You can highlight multiple at once. You can use the eye here to toggle the highlight visualization. We do have this pen thing. This option is mainly for correcting any segmentations that you're trying to work with manually. I don't even really use it a whole lot, but you can draw on the image, and this will actually directly input structures onto the image, so they get like the highest label, mainly for working with binary segmentations. But you can, like, let's say I'm trying to segment something and it didn't get something here, I can like manually fill that in, and then you can see it alters the image a little bit. Similarly, when you're using this, you can erase stuff with the right click, control mouse wheel to resize it. It also has a fill can. If you press F and if you press D, you can write into multiple Z-planes at once if you want to, if you're trying to fix something that's deep in 3D. And then looking down here again, go left and right. This moves you through the Z stack. This image is only 2 slices thick, so we're not really going to have much to work with there for this case. Some other things down here. This gives you a scale bar, mainly just if you want to screenshot something and have scaling information. This active image thing, some of the functions that you run in NetTracer3D will just automatically execute on whatever is set as the active image here. So just keep that in mind whenever you're doing any image processing options. Back up here, this is where you're going to load and save your data. This is where you're going to analyze your data if you want to quantify anything. This is where you're going to create the networks, and you can also process your images, mainly editing segmentations in various algorithmic ways. This is sort of just a few more highly specific image processing options. And then here, this is something that you might want to take a look at, mainly these XY scale and Z scale properties, because when you're working with your 3D data, the Z step size might be different than the resolution for X and Y. As I set this up, this is always going to be the same in X and Y, so you can't have an image where, your X pixels are, 3 microns and your Y pixels are 2 microns. That doesn't really come up that much in my experience when working with images, so I just combine them into one property. Just note that like a lot of functions sort of assume that this will be a certain value. There are a lot of functions like scale distances based on these values that you input here. So if you want your values to correspond to true distances in your image, you just want to make sure that these are set correctly. It will try to detect it if it's in the metadata, but that's not always the case. Yeah, and you can also sort of get an in-GUI tutorial if you just click on this tutorial thing. This is sort of more text-based, not super in-depth, but if you're ever just lost, you can do that. Or like I said, you can go to the documentation itself. All right, and before we move on to the final part of this tutorial, I just want to briefly go over saving and loading. So that's going to be done through the file menu. You can, we have these channels here. All of them can be loaded from this load menu. So the nodes are going to be the stuff you want to connect in your network. The edges are going to be a medium that you're using to connect them. You don't actually need an image for that directly. There are other ways to connect your nodes, and then the overlays are just sort of for visualization purposes. You can load on top of them. But the main way you're going to want to usually do it is through the load network 3D object option. So if I do save as network 3D object, find a master folder here and find a new output folder. So I'll just name it that. Right, and then if I were to start a new session, what I can do is I can do file load network 3D object, find my previous session wherever that was. So I put it in here. And then when I do that, it will load in. In the bottom right, this is just information about the network, sort of just telling you exactly what nodes are connected. If I could go down here, I can save this as a spreadsheet or as a few other file types that are compatible with other network analysis software. I can save any tables up here. This is where any analysis goes. And I can also export that as a spreadsheet. I talk a little bit in some of the documentation about doing this through Anaconda. All that is like, here we installed it directly on my Windows PC with Python and all that stuff. Sometimes if you're working with multiple different Python packages, they might have incompatibilities with each other. And so it might be a good idea to make a dedicated package environment just for NetTracer3D. So Anaconda is just a program that manages Python packages and environments for you. So you can download that, and then you can set up a sort of dedicated NetTracer3D environment and install it there. I'm not going to go over how to do that. There's lots of online resources that can tell you how to set up an Anaconda environment, so just probably look for one of those. Regarding this thing, I do have a few GPU functionalities in the program, but they're not like super robust. But if you want to, it's not super hard to set up the additional stuff you would need. So if you were going to want to set those up, you would need to download this thing called the CUDA toolkit. Basically, it just depends on what NVIDIA GPU you have, and you can kind of look up what your GPU is compatible with, and then you would want to install the corresponding toolkit, and then it's basically just something you download and then you get walked through by an installer. I don't actually have anything that relies on PyTorch directly, but some useful segmentation options that you might want to use in tandem might require PyTorch. All PyTorch is it's just a library that does GPU-based machine learning stuff for the most part. So installing PyTorch can be a little weird. You kind of just have to like select all these options, tell it which CUDA toolkit you have, and then you'll get this like really long install command, and you just run that sort of how like when you install NetTracer3D.